Hello, everybody. Welcome. I hope you've been having a good time at Playtime here in Brussels. My name is Paul. I'm a developer relations engineer. I work out of the Zurich office, and my focus is to lead the TV and cars teams. I'm here to talk about Compose. Compose is the way to build beautiful, responsive, dynamic, and engaging UI across all of Android, and it's supported on all of the different Android form factors. And as you know, I'm probably speaking to the choir here, but it's a framework that works across phones, tablets, TVs, small cars as well, watches, and even XR. And today, I want to show you how to use Compose specifically in cars and TV. So the versatility and the reusability makes Compose the Swiss Army knife of Android app development that developers absolutely love. And you don't have to take it just from me. Here's some words from Vitus from SoundCloud. He had to say about building their TV app from the ground up in Compose, help them reach new users and market, and increase their global reach. And he went on to point out how they could overhaul their entire application design system and build new features with 45% less code. So you can read more about SoundCloud's Compose journey on the Android developer site. On the developer blog. So one point of feedback that I often hear, especially on TV, is the concerns around performance of their app, especially on the low-end hardware that we see in TV. And there are two key metrics I want to focus on for a minute for measuring UI performance. The first is the time to first frame, and the second is the average jank rate, which is a representative metric for signaling dropped frames due to slow UI recompositions. Internally at Google, we have a benchmark that is based on the Google Play home screen, and we frequently review the benchmark to see how things are trending and therefore making good strides in improving performance on Compose. And you can see that there are great improvements that we've made over the years are there. The time to first frame has gradually decreased. This is a wonderfully dropping line. And what this effectively means is that the time to launching your application feels snappy. Now, this is a great line, obviously, but I hear you thinking, that's great, but will Compose ever perform better than Views? And that's the neat thing. It already is. Up there in the red line, that's Views. So Compose has already been outperforming Views for quite some time in the time to first frame. By leveraging R8 and baseline profiles, the time to first frame on Compose is already dramatically faster than inflating XML views. So what about then the jank rate? Here too, we've made huge strides in reducing jank rate in Compose, which is especially beneficial to those low-end devices I was mentioning. We reduced the jank rate by 76% in the course between 2024 and 2025. And here too, how does that compare against Views? Well, the jank rate is already much lower than Views. But wait, there's more, because these metrics are from March, from the Compose 1.8 release, and since then we've had the Compose 1.9 release, and those numbers are even lower. The jank rate is so low on Compose that it is effectively reaching zero. So I hope that this dispels any concerns around Compose performance, and with that out of the way, we can finally talk about building Compose applications for TV. So Compose for TV is a library, it's a component library that makes it easy to begin building your first TV app in Compose. And as a developer, you can use it in conjunction with Compose Foundation and Compose Material. We have a detailed design guide that helps you in building modern TV apps that emphasize focus and make it abundantly clear which component has focus. Now, this is really important because with a distance between the couch and the TV, it may be hard for users to see subtle focus indicators like those that we're more familiar with on mobile. And that's especially the case in an environment where environmental or ambient lighting may result in poor contrast. And these panels don't always have a good contrast ratio anyway. So all the components in Compose for TV come out of the box with bold focus indicators by default and allow for customization. So you can use and even combine indicator styles for components like these cards that you see on the screen that change in size, outline, glow, and color. And you can even define those indicator styles within your Compose theme so they can be reused throughout your application. And all of this is included in our Compose for TV Jetpack library. We've recently updated it to version 1.1.0 with some focus enhancements, and all of the updates inside Compose Foundation and Compose Material, such as other focus improvements and behavioral changes in Compose 1.8 and further in 1.9, can be used in combination as well. So to support you guys as developers with this, we've published a code lab on focus management earlier this year. Now, I highly recommend going through this to learn about optimizing your app for physical input, not just for TV, but also including laptops and tablets and other large screen devices that have attached peripherals, like Bluetooth keyboards, for instance. What I will do is I'll cover the most important parts, and I'm going to start with taking a look at how you can take control over setting the initial focus. So suppose that a piece of our app contains a column of 3 cards, in this example on the right. And we want the first card to receive the focus by default instead of a different component that might exist elsewhere on the screen. To do this, we define a focus requester, and we're sure to remember it. If you see that as the top line up there. So the first card is remembering the focus requester. And then we provide that focus requester as a modifier to the first card when we actually declare it. And we do that by providing it into the focus requester modifier. And I wish I had more to say about that, but that's basically it. By remembering the focus will be restored correctly, and as the user changes focus and navigates back to the screen at a later point, the focus will also be restored. So you get the initial focus as you requested, and it will also remember any focus change that the user's made to restore it at a later point. So that was actually really easy, right? Let's take a look at a more complex case. Suppose we now have a column with 2 rows. On our second row, we have more elements than the first. So you see here the cards 2 through 4. And what we're seeing here is that when we press the right D-pad button from card 1, we unexpectedly end up with a focus in card 3. Now, the reason that this is happening is because Compose makes a best effort to identify the component that can receive focus to the right of the first card. Now, usually that makes sense because it allows the user to navigate through focus by pressing the D-pad keys. But in our case, if we think about this being, for instance, a browse screen inside a conventional TV app, we might have rows of cards and posters for users to browse. And what you'll usually see there is that when you reach the end of the row, the focus remains and doesn't move to the next one. So the implementation of this would actually look like this. Like I said, it's a column that contains 2 rows. The first row, it's just the first card, and the second one, we've defined a row with the cards 3 through 4. By declaring our row as a focus group, entering focus into it is treated as a group. And that means that this focus group no longer resides to the right of the first card. It's left aligned with the first card, which means if you try to bring focus from the first card to the right, there's no element for it to bring the focus towards. So in effect, what that means is that when you press the D-pad right button, while the first card is selected, it will behave as expected. So when I click right from card 1, nothing happens, which is what we want. So while this is great, and it's probably what you already want if you're building a TV app, we may consider another improvement. Maybe we want to make sure that the user can scroll horizontally to the second row, and when they navigate into the content card details, it's remembered when they return into it. So let's take a look. Here again, we see our implementation. Where we had left off, we have the focus group already there. And now, as it turns out, all we need to do is specify a focus restorer as a modifier to the row. And simply by providing a focus restorer, when the user navigates between the rows, they can pick up where they left off. So observe now in this animation how navigating from the first card to the row below restores the focus where they left off. So going from 1 down to 2, navigating to the right, going back up, and bringing the focus back down restores it to where the user left off. Well, turns out that was pretty easy too, right? This code lab covers this in detail, and it actually includes more complex cases, like combining all this into a UI with tabs, for instance, which also have their own focus behavior. This also demonstrates how to include test coverage, so I definitely recommend taking a look at how that's done. Great, let's now switch up a little bit and talk about cars. We have just published our completely new Design for Cars guide. For the designers in the room, get inspired by all the kinds of in-car experiences that we've included here. And it's important, as you're thinking about this, to differentiate between the two kinds of car integrations. We have Android Auto, which is displayed here at the top, and then we have Android Automotive OS, which is the embedded version of Android that runs inside your vehicle, including Google Play, in Google built-in vehicles. And it's also important to think about two kinds of experiences. The kinds of experiences that people have inside their vehicles while driving, such as navigating, or the kind of experiences what they have while parked. And it's this last area that I want to focus on, because for safety, when a vehicle is in motion, apps are restricted to our template library for navigation, media, points of interest, and our other supported categories. So instead, let's focus for a moment on the parked app experiences and where you as app developers that are thinking about building adaptive apps that include cars can bring your conventional tablet apps and UIs into vehicles with Google built-in. Before I tell you exactly how to do that, I want to focus for just a minute on our car app quality tiers. We have 3 tiers of app quality, and you'll see these kinds of tiering being used across Android in large screens and in XR as well, where we have defined basically at the lowest tier a car-ready application. And a car-ready application, we'll explore this in a little bit more detail in this a second, is basically an adaptive mobile app that runs in compatibility mode. And we're going beyond that, building better car app quality applications, you can go to car optimized experiences, and then finally in car differentiated. And I'll explore those at the very end of the session. So in the car ready tiering level, which is the bottom tier, you can explore building your first app for Android Automotive OS by bringing an adaptive mobile app into a car while the vehicle is parked. And this will run in a compatibility mode. And what I mean with compatibility mode is that Android Automotive OS will take care of overlaying a back button onto your application so that the user can always navigate back. And it will make adjustments for DPI scaling so that it works at the arm length for interacting with the vehicle's head unit. Now, the terrific thing about the car-ready mobile program is that as an app developer with an adaptive app, you effectively have to do nothing. By participating in the car-ready mobile program, you can take your existing adaptive app and simply opt it in through Google Play to run in cars with Google built-in. So you can build your app in Compose in all the ways that you know and love, building a beautiful adaptive application according to all the best practices that we've heard today and in the various conferences that we've seen over the years. And with that adaptive application, it will simply work inside the supported vehicles. And we've already launched over 150 adaptive apps as part of this program, including games, browsers, and streaming video services. So with all the time you basically had to not develop an Android app for Android Automotive OS, with all that spare time that you now have, you can explore the ways to go beyond just car ready and optimize your app to include driving features within the car app library templates, or make improvements to your adaptive app that are tailored to parked app experiences. What I mean with that is the compatibility mode, for instance, that I mentioned earlier, including the overlaid back button. You could include a back button within your application and also deal with the DPI scaling with more granularity to take control over how your UI looks pixel for pixel on the vehicle head unit. And then to differentiate in car differentiated tiering, explore the ways that you can uniquely leverage car hardware and screens, for example, by seamlessly transitioning between your application UI as the vehicle moves from parked into driving states. This is one of our current developer programs, and I encourage you to go check out the Android for Cars developer site to learn more about current developer programs to really let your application stand out. Okay, now let's talk about testing. Now that you've done all the work to develop your application, you want to test it. And we know that testing vehicle integrations can be really challenging. Of course, we have the Android Automotive OS emulators, which are a variety of different versions that are available within Android Studio. But we now also launch an early access program that adds physical devices to our Firebase test lab. And this brings direct device access directly to your fingertips while you're developing in Android Studio. And we've also introduced Android Automotive OS as an image for the Pixel tablet, which basically means that you can take physical hardware and test at your desk. And the most recent version, the most recent image on the Pixel tablet also includes Android Auto. So perhaps you've noticed that today, here as well, there's a theme of the Compose integrations across Android form factors. Google is making it easy for you, both as developers and designers, to build Android applications that run on anything that Android runs. And that's really what it means to build adaptive apps. And so far, I've spoken theoretically about how an adaptive app that looks great can run on TV and cars. But you may be asking yourself, can I actually see an application with a single code base that runs across phones and tablets and desktops and cars and TVs and XR headsets? And yes, the answer is yes, you can. Earlier this year, my team has adapted the Jetstream open source sample that was initially designed for TV to leverage the new Compose libraries and extend it to basically all Android form factors. And this approach reuses the most amount of code between form factors. It works especially well if the UI doesn't significantly differ amongst your varying surfaces. You can see how the grid of content details, and playback screens are very similar between TVs, tablets, and phones in this sample from Jetstream. And this is a content browsing sample, so that works extremely well because the UIs are just very similar across the surfaces. And thanks to adaptive app design and self-adapting composables, we reuse so much code that adding Android XR was a breeze. So be sure to take a look at this open source sample on the GitHub. That's the Android GitHub repository. While Jetstream focuses on maximizing code reuse in a single module, the Jetcaster sample demonstrates an alternative approach using a robust modular app structure. The Jetcaster uses an architectural foundation of distinct application modules. In this example, you'll see separate application modules for mobile and TV. These strictly handle performance platform-specific UI logic, while the shared business logic and data models exist in shared library modules. But then also, shared UI components exist in shared modules as well. By keeping reusable code in these libraries, especially the bits of Compose within the shared UI module, we maximize code reuse and ensure consistency across platforms while simultaneously leaving enough sufficiently separated differences between the modules across form factors to allow them to be customized. Testimonials, performance insights, best practices, developer programs, samples, and tooling. I think that was everything that I covered today. You now have everything that you need to build with Compose on every form factor. Thank you for listening.